How you doing? Chontag back again here. A little bit more of a sciencey thing that talks a little about circuit boards and resistors for today. But I just wanted to say thank you so much. I've only been on YouTube for like a day, and I already have people subscribing to my channel. Thank you so much. This is awesome. Honestly, I'm doing this for the parents, for the people who are out there who have kids who want to see something. I'm doing it for people who just want a simple little education and just want to break from the from the stuff that's happening right now with all the things. We're all indoors. A lot of us are indoors. Let's kind of try and maybe learn something, maybe a little bit educational, maybe a little bit entertainment, and focus on something that I actually really like to do. So thank you so much. Your support is awesome. Your comments are awesome. Let me know if you like it. Let me know if you don't like it on here. But today, let's learn something a little bit about circuit boards right here. So I'm actually holding in my hand a small circuit board. This is really just about the same size, as about 2/3 the size of a microscope slide, approximately maybe 2 inches by 1 inch. I think it's just about the plus or minus tolerance of some kind with that on there, whatever the variability happens to be. So you're looking at this on here, and let's put this on the screen. You're actually looking at 3 different things that all kind of make every single circuit board work at its fundamental basics. At its fundamental basics, every circuit board kind of has the same 3 things somewhere on it, although like circuit boards, motherboards that are inside of a computer have a seriously larger number of these. Every circuit board's kind of got the same thing. The silvery colored things that you're looking at on here, these are what we would call pads. And are made out of metals that help electricity go from one spot over to another. An electronic component is actually going to be attached over to some of these pads here, depending on what the pad happens to be. Or in some of the cases, maybe not an electronic component, just a place like, for instance, this square right here is actually going to be a test point for an electronic component. Now, the green stuff that's on here, the green stuff is what we officially call the solder mask. In a nutshell, it's the thing that protects all the stuff that's underneath it, as well as prevents solder from being able to connect up to it. So solder is that alloy that we've been working with. This metal wire that comes off of the spool that I've got here. So I've got my little solder spool that this kind of feeds off onto the side, and the solder is able to very easily connect up to any one of those pads that are on here. Solder, when I heat the pads up, will attach itself down to these pads. But solder does not connect very easily up to the green solder mask area. And allow me to kind of demonstrate this here. Let me just get my soldering iron out, move my multimeter out of the way. Excuse me, pardon me, can I come through here? Is that all right? I got my soldering iron currently set up, my Hakko soldering iron station, set to about 650 degrees Fahrenheit. And I'm going to go underneath. I'm just going to go over to the test point. There's actually not going to be a component that's going to be connected here. And I'll actually kind of zoom in a little bit so that we can kind of get a little bit more up close with the test pad here. Focus in on that little pad. Can you all see that okay? Good. Yes. Yes. Very good. All right. So now we're going to come on in. I'm going to touch my soldering iron down, which applies heat down to the pad. And now I'm actually going to connect some of the solder down to the pad itself. And we can see that solder actually flows onto the pad and actually sticks to the pad. It forms kind of a bond up with the metal that the pad's actually made of here. Now, this pad, at this point now, the soldering is hardened over. I don't know if you can kind of giving that a good old whack with my tweezers right there. Thwack. And so at this point now, that has actually formed a bond. But if I were to try to say, for instance, do this to the green area, so I'm going to try and connect put some heat over to the green area. That beep is the indication that my soldering iron has reached temperature. So here's the green area next to it. And if you notice, it's not doing it. There's nothing that's sticking down to it. In fact, if anything, it's just sticking to the one thing it can stick to, which is either the iron or itself. You see that guy right there? It can't stick to it. It can't stick to it. This is a little piece of solder that just will not go anywhere. But as soon as I bring this over to a piece of metal, or anything like that, it sticks to that quite easily. You see that? You see that on there? I hope so. That seems like it's kind of dark. I'm going to try and demonstrate that again here. Let me boost up the gain just a little bit. So I'll turn up the gain. I know the Microscopy Society is going to be telling me, no, 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 you turn up the exposure. But at the same time, I'm just going to kind of wing this around just a little bit right here, see what this kind of looks like. So here I've got the greenish area, and I'm going to try and solder down to the green solder mask area there. I've actually pulled the blob off the main solder wire right there. I pulled the main spot, and it's not connecting up. It's not connecting up anything to it. But as soon as I bring this over to say, a big honking pad such as R1 right here, as soon as I bring this over to it right here, that solder will stick to that pad quite nicely, actually. See that? See, but it won't stick over to the green area that's sitting right down next to it, though. So an interesting item with it on there. Oh, sorry about that. That would be my emails are currently being emailed. Someone's emailing me. Well, who knows what that is? Sorry about that. Anyway, the solder sticks to the pads, but ultimately does not stick to the solder mask. And some people have seen different colored circuit boards in the past. Some people who may have worked with Apple, or well, now gosh, where did they go? Of course, I would drop that over while I'm recording, and I can't necessarily stop recording to it on there. Or can I stop recording? Do I see where they went? Oh my gosh, they went all the way underneath the table. Watch me grab this with my foot here. Excuse me. There we go. Some people have seen different colored solder masks on circuit boards before. I know Apple products and many high-tech products, they make it the color black, which is actually one of the more expensive colors, I've been told, that solder mask is made. Everywhere I've gone to, green is like the default cheap, easiest one to do. But I've seen every color underneath the sun. I've seen white solder masks. There's an American company that does purple solder masks, which is it looks really cool. I haven't ordered from them, but it does look really neat. There's blue, red, yellow, all sorts of different kinds. Some of them mean different reversions of the same type of hardware that's used. Some of them are just there for the colors and sake purposes of it, though. Green is usually the more the cheaper one that's on there. So just excuse me, something that I've seen before. All right, so now we've got the pads, which are the silver parts here. We've got the green, which is the solder mask, and then the lettering. So the lettering has a couple of different things. They're what we call designations on the circuit board that indicate back to a design document, what we call the schematic and the layout, to indicate which component goes where on the circuit board. Most of us in the industry call this the silkscreen layer. So because the actual way that all of this is made is very much a silkscreening process, which is similar to how t-shirts are made, the old you put the image down through a stencil and push the squeegee down through the stencil and to get that made. So it's kind of the same thing with it. But anyway, the silkscreen just serves as more of a marker of designations to it, is what it does. But yeah, all of these components that there are here, there's an R7, there's an R8, there's an R9, and there's an R10. This is where electronic components actually go and get connected. And an example of an electronic component that we would potentially connect up to there would be, is that the one I wanted to grab? That's not the one I wanted to grab. Is that the one I wanted to grab? That's the one I wanted to grab. Yeah, this guy right here. See him? Hey, little dude. Oh, sorry. Hey, where is he? Oh, there he is. You see him there? It's kind of hard to focus in with my laptop screen being what it is. Zoom in real close. Zoom in, quote unquote. There it is. All right. Now, how big is he really? Well, let's put him underneath the microscope here. And at this point now, kind of moved him into place, and there you have it. That is an electronic chip resistor. In an earlier video that I just did today, we talked about some of these electronic components called resistors, and what they do is oppose the flow of electricity that's going through them. What you'll actually more or less find on the inside of a more traditional circuit board are resistors that kind of look more like this, more like a a shoebox almost look to them, if you will. They're what we call chip resistors or surface mount resistors, is what they are. These surface mount resistors are smaller in size typically. They don't handle quite as much power going through it as big ones, but tend to be a little bit more difficult to handle, is what they are. The larger ones, and this is, believe it or not, this little guy right here is actually kind of a larger size chip component for many companies in terms of what they make. That larger size component there actually typically has a numeric code that's on it. If it's got 3 digits like this actually indicates the quantity of resistance that the resistor happens to have. In the case of this, resistance is measured in a unit. You know how like we measure our height in units of meters or feet or whatever it happened to be. Like all countries use different things. I get that on their inches, feet, miles, whatever. Who cares? You know, so kilometers, meters, micrometers, whatever. These are the unit of measure for resistance. The electrical phenomenon of resistance is measured in the unit of the ohm, the OHM, the ohm, which is abbreviated as Greek capital omega. Greek capital omega is kind of like an upside down horseshoe-shaped thing is kind of what it looks like. Is what it is, where there's a hu and then a and then a hu, or like, kind of like something like that with it there, with those sound effects in there. So the resistor that's right here. So this resistor actually has its resistance that's been marked on it in a numeric code. The numeric code is as follows. For 3 digits, this is for 3 digits only. The first 2 digits on there are just whatever they happen to be, such as in this case a 3 and then a 9. But then the last digit that is on the resistor actually happens to be the number of zeros that follow the other 2 numbers. So this number, even though it says 391 on the actual resistor itself, it is 3, 9, and then a single 0 that follows the 9. So 390 ohms of resistance is what this happens to be. We'll connect this resistor into place here, but just to go over like some of the other resistors that I've kind of pulled off to the side. For instance, another resistor that I've got here. I've got a second resistor here. Oops, it's upside down. Excuse me. Sorry. Can I come out here? Okay, excuse me. Pardon me. Sorry about that. Oof. Excuse me. Oof. Hey, let go. There we go. 222. sound like a train. Tutu train. Yeah. So the 222 is the 2 and the 2. The first 2 2s are just what they are. They're 2 2s. But then the third of the 2s is the number of zeros that follow. So this is a 2,200 ohm resistor, and you can look at any circuit board that you can pop up, and the numbers are on there. Whatever that last number, whatever the number that's over to the right, typically tends to mean the number of zeros that follow that particular resistor. Now, some of you might be saying to yourself, what if it's a really small number, in which they do exist out there. We'll get to those a little bit later on at some point here. Another example, though, just to kind of showcase there, what if we've got something like, here we go, excuse me, pardon me, excuse me, oof, excuse me, oof, 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 sorry, bump. All right, so that one says 750, right? But that last number is the number of zeros that's at the very end of it, so it's actually just 75. Is all that it is, 75 ohms of resistance. Another one that I've got here, do I have another one here? Yes, I do. Oh, excuse me. Here we go. Oof. There it is. Oof. Excuse me. Oof. Excuse me. Pardon me. Oof. 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 There. 155. So that is 1, 5, and then 5 more zeros following after the first of the 5. So it is 1, 5, and then 0, 0, 0, 0, 0. Right? So that is 1.5 million ohms, or what we would call a mega ohm. Mega is it's an abbreviation for prefix based on the number of numbers there. We'll cover those a little bit later on. We'll get to that at some point. Anyway, let's solder these resistors into place, shall we? Yes. All right. So let's take the resistors here. Excuse me. Pardon me. I'm going to start with the first one on here. My general soldering method that I apply towards my solder method will be as follows. Oh, something kind of cool. So we kind of, I don't know if you see this on there. See how the pads are kind of like linked together with a little line? Like for instance, these two pads have a little line between them. That is what we call a track or a trace, depending on what you are. I've always traditionally called them traces, but I guess they're called tracks. They could be either one with them. But the track that connects between the two pads right there actually is made of metal, but it's covered by the solder mask, interestingly enough. In fact, if you actually zoom in very, very carefully and we focus in, you can actually see a square-like hole just on the outside of that pad there. You see that kind of pad? See that pad there? You can see that just barely on the outside of that. You can see a little pad, and that's with it there. And as it turns out, that pad is actually the open hole for the pad that's there. But underneath it is the solder mask, which is there protecting the track from not only from being soldered to, but also just other sorts of things like erosion and other things. It's a form of protection for that particular guy. So here is how we are going to solder some of these resistive components into place. First thing is first, I'm going to take this tube of stuff right here called Fluxing Agent, and I'm going to actually dispense it on each one of my resistors. Pardon me, excuse me about that. Right? So every single one of those my resistors, I've actually got a small amount of fluxing agent. Flux, when activated, when heated, turns into an acid and helps provide a better contact for the circuit component down onto the circuit board. So without further ado, let's heat it up, shall we? So soldering iron in my right hand and solder wire in my left hand, because I'm a right-handed person. I am actually going to solder the left-handmost pad of R7 here. There we go. I'm tinning it. I'm applying what's called a tinning. So if I zoom in kind of carefully, I have heated up the pad and applied just a small amount. You might see a little bit of some steam kind of hissing off from that. That steam is that's not steam. Those are fumes from the fluxing agent that is activating and heating up and providing overall a better solder joint for me. Now I'm going to heat up. I'm actually going to heat up all three of the bottom of these three pads. So I'm going to come here, apply a little bit of some heat, and apply a little bit of solder, heat, then solder, heat, and then solder. Right? So three of those guys there, looking good so far. Right? So now we're going to take my first of the resistors. Let's take the smallest of them. Can you tell me which one of these is the smallest? Let's start with go for the 750. You look pretty good there. There you go. We'll just let it sit in the fluxing agent. This fluxing agent is tacky. I prefer the tackier fluxing agent myself. It's just what I usually commonly work with. I find it better working with all sorts of components. It's easy to clean up at the very end with water or alcohol of any sorts with it. So at this point here, I'm going to take my chip resistor. I'm holding it in my right hand with the tweezers while moving my soldering iron in place. And then you see that? The solder melts at this point. Now I'm going to take the chip and look at that. It just sort of got sucked into place is what it does. Look at that. And now it's like stuck in that little pad there. Isn't that kind of cool? Now if I take this away, the pad has cooled down at this point, and that chip resistor, that's excuse me. That's there. That's there at this point. Now I'm going to actually do the same thing for R8, R9, and R10, but I'm going to get a little bit closer for these guys so you can actually kind of watch this effect happen. I always thought that this was kind of just a cool effect even when I first started doing this. I thought this was kind of a very, very neat effect. All right, so I come down with the soldering iron in my left hand. I'm going to come down and I'm going to touch the solder, which melts it. I'm going to apply the chip into the flux. I'm going to touch the chip to the molten solder, slowly but surely moving it into place there. Right? Like that. And then let it go. And there we have it. That one is soldered into place. We'll move down over to R9. So, let's see here. And we'll take the next largest one. How about the 220? By the way, by the way, underneath each one of these resistors is actually just a bare white piece of ceramic. Most of the electronic part of the resistor itself is actually just the thin amount of black layer that's actually on the top of it. It's only like 5% of the overall bulk that makes up this chip resistor. The rest of it's all so I can hold it with a pair of tweezers, or so a machine can hold it with a mechanical pair of tweezers, then that kind of thing to it there. So I'm going to drop the resistor down into here. I'm going to come down with I'm going to make sure I got enough light on here. Can you all see that okay? Yeah? So I can come down here with my soldering iron, melt the molten solder, make sure it's nice and hot. Take that, and look at that. Look at that solder just kind of creep up the side of that chip resistor like that. That is really, really something. Isn't that really cool? I think that's really cool. This last one here, let's whoosh. Let's take a look at it really, really up close here, and I'll kind of zoom out for this there. So when we melt the excuse me. There, we'll get you right about. Excuse me. This is for the 1.5 million ohm resistor. That's what it is. So first thing I'm going to do, I'm going to grab the chip resistor. There it is. There. Excuse me. All right, still on the screen, looking good. Yeah. All right, now we're going to come down with my soldering iron in my left hand. I'm going to touch it to the molten metal. And now I'm going to push that into place there. And look at the solder just kind of creep up the top of it right there. See how it's like moving up the top? That's solder that's currently like just kind of crept up the top of the resistor, and it's sitting on the top of that resistor there. Isn't that really something? That's pretty neat. And I really honestly like, did I mess this up? Like, do I need to fix something here? I'm just going to, I can at any given point in time just sort of come back in with my soldering iron, touch it, remelt it again, and now I can move it, I can take it out, I can put it back down again, let it go into its right spot. It's usually best when you do it right from the beginning. Let it kind of stay there, and it's looking pretty good, don't you think? Yeah. I'm going to now take my soldering iron, or my tweezers down, move my soldering iron back to my right hand, and I'm going to come at each one of these resistors, starting with R10, the 1.5 mega ohm resistor, and I am going to come down to here, and then touch down to there, and watch how it just kind of flows right on over. See that? There's a really, really nice touch to it. Same thing over here with R9. We're going to come into place, touch this guy right here, and then move that guy on over there. Yep. And then come to this one here, touch you, and put a little bit of some solder down. It really doesn't take. I am holding my hands very, very still. Oh gosh, I hope that got caught on camera. I can see it in the microscope just fine, but hopefully it did. If it didn't, I will do the same thing here for R7. There we go. So I'm touching it down with the soldering iron. I'm keeping my hands fairly steady while I'm doing this, and that's just, it's something that comes with practice. It's something that anyone who's been in this industry will say, it comes with a whole bunch of practice, is what it does. Practice tends to make perfect, which is typically what I tend to tell my students with it as well. It's just one of those, like, the more often times that you do it, the better off that you're actually going to be able to get with that on there. The last thing that we would do is the fluxing agent is still technically on there. It is technically considered bad to leave any sort of fluxing agent on there, so we're going to come at it with a little bit of a cleaning solution and alcohol swab. Just a little bit of it on here just to kind of clean this stuff up. Normally speaking, we actually kind of run our parts through a ultrasonic cleaner, which helps to kind of clean it up. But I've actually found that this particular fluxing agent that I'm using, which is actually recommended to me by another professional who is in the industry and does a fantastic job of showing a bunch of how-to videos while he runs his business. Louis Rossman, I can't say enough good stuff about that guy. I think what he does on his channel is absolutely fantastic. And if you want to see someone who does this like professionally, like for a living, I'll try to link him at some point into this video because he is absolutely worth watching based on his how to do these sorts of videos with it on there. But yeah, now all the electronic components are actually all connected together all at one time on this circuit board. They're all electrically connected up. So that is how we do soldering and the reading of resistors. There's going to be more solder videos. There's going to be more resistors. We're going to be building circuit boards throughout the many next couple of videos here. So if you have any ideas for me, throw them in the comments below. If you think that this is really awesome, let me know. If you don't think this is awesome, let me know. Whatever, or don't let me know. It doesn't matter. If your kids are happy or if the parents are happy, that's a win with it on there. All right, so hey, thanks very much for stopping by. We'll catch you around next time. See you later.